My name is Sandeep. I'm a developer advocate at Google Cloud, and today we're going to talk about world-scale microservices. That woke you all up, didn't it? So yeah, let's just jump right into it. This is a somewhat advanced Kubernetes talk. So if you're here, I expect you to know what Docker is. Yeah? Okay. What containers and orchestrators and things like that? Okay, we're good. You're in the right room. So we're going to architect an app from start to finish that has to work around the world, store state, be fast, and a new term I just invented called low ops, because it's not no ops, right? And we only have an hour to talk about it. Yeah. So what are we going to do? Memes. Memes are the best. These are legal approved memes. Yeah. Of course, I'm just going to give a caveat. Everything you see here could have been built in a static JavaScript page and launched in a CDN and been globally distributed. But you know what? I wanted a good microservices example, and hello world just doesn't cut it. We need to build something somewhat real, but not too complicated. And so a little meme generator seemed right up the alley. And so here's that agenda, right? We're going to talk about what we're building, and then we're going to go with the stateless part and the stateful, multi-cluster, and then configuration, and then my favorite category, other stuff. Overview. So how are we going to do this? We're going to do something that looks like this. We're going to have 6 different microservices. There's 5 on the screen, but there's a secret 6th one. And when the user comes to our landing page, they're going to come in to the web server. And the web server will just hit the Redis cache. It'll get a list of 10 images and show it. The HTML will be served, and the images will be pulled from GCS regional buckets. Right? Makes perfect sense. When you want to make a new meme, it gets a little bit more complicated. Again, the request comes into our web server, and now it talks to the meme creator microservice. And all this does is generate a JPEG and stream it back to the web server. Now, at this point, it's just going to stream that JPEG straight back to the user, right? Very, very fast. We're not waiting for it to be stored anywhere. We're not waiting for replication, nothing. At the same time, we're going to send it to the image store service. Now, the image store service is the one that's going to send it to the regional bucket, store the image there, and get the link back. Now it's going to take that and the metadata that was used to generate the image and put that into the cache and into the MongoDB database. Now, unfortunately, unlike Cloud Spanner, MongoDB does not become consistent around the world magically. In fact, it's very inconsistent. So we're going to run it in one cluster instead of all the clusters. Right? So these are all local clusters that we're running. And the MongoDB database is in one of the clusters only. So we have to have some sort of cross-cluster service discovery as well. And then search. For search, it's a little bit simple again. The web request comes in. We talk to the image store service with the requested terms. It talks to MongoDB for the links. It gets those links. And it serves it from the appropriate regional buckets. So the interesting thing here is the search is around the world, right? If you generate a meme in Japan and it's stored in our Tokyo bucket, you can still find it in the United States. But the Redis cache is local to the local cluster. So this is a pretty reasonable architecture, nothing too complicated, but it's using 6 different microservices, which I find really fun. And of course, to do this, we're going to use the power of Kubernetes. And we're going to use the power of Google Container Engine. Oh yeah, it's the only way I'm going to ever wear this shirt. Like, who invented this thing? It's like half the shirt is the logo, right? So here we go. I got to wear it at Cloud next. So let's start easy, stateless. I expect most people in the audience to know exactly what I'm going to do here. So the meme creator service is a great example of a stateless app. All it does is take in a few simple parameters and return a JPEG. It's 100% stateless and configless. It's one API, a get with URL parameters, no dependencies. It's a single standalone Docker container. So here's the things we need to run the stateless service. The first is the concept of a pod. Again, this is more 101, but we had to learn this to go further, right? So you have a group of 1 or more containers that share localhost and are always scheduled together, right? They all share the same IP. They live and die together. Then we have deployments, and basically this says, I want so many pods to run, what the pods need, and the deployment kind of takes care of the rest using a replica set. And we have a service. And because we can have arbitrary number of pods, we need a stable endpoint to do service discovery and load balancing. So if we look at the meme creator service and deployment, it looks something like this. You have a bunch of pods with a random ID, and let's say I want 3 of them. When I have a request come into the meme creator service, it'll round robin load balance to an available pod. That's it. If a pod dies, it'll be replaced by a new one with the new ID. We don't regenerate pods. And so that's very basic. This is a hello world of Kubernetes. Let's just go through a quick demo. And I'll also record my screen just in case. Cool. So here we have, I'm going to run a deployment with 2 replicas with the Nginx image and open up port 80. So our deployment is created. Very easy. What does that look like? Something like this. Now, this is the full YAML, of course. In real life, you would write a lot less. You can see that I have 2 available replicas. I have 2 replicas in my spec. Port 80 is open. The image is Nginx. Exactly what we specified in that command. Now what I'm going to do is expose that using a load balancer. So I'm going to go kubectl expose and the Nginx deployment and type load balancer. This, of course, as most of you know, will spin up a Google Cloud TCP load balancer. And TCP load balancers are not global. They're very regional. And you can see that the Nginx deployment has been created, but the external IP is still pending. So in a few seconds, we'll get that external IP. Let's get it. And the fun waiting game. We're going to be doing this a lot. It's called It's not even exciting. I'm just going to keep going. Can we switch back to the slides? I'll show you that later. All right, cool. So then IP would have come, and we would have seen hello world from Nginx. Very exciting. Not really. So let's go to something a little bit more exciting and a little bit more complicated. So stateful, right? Containers can have state. And the best example of this is MongoDB database. We're not running this in GCE. We're not running this somewhere else. We're running it in Kubernetes. But there's problems. There are serious problems with this, especially if you try to do it with a deployment and replica sets. A MongoDB replica set, not to be confused with Kubernetes replica sets, are complicated to set up and are complicated to keep running. Every single instruction on MongoDB's website requires you to log into a machine, connect to the MongoDB client, do some commands here and there, set up your rs.conf, do all this complicated stuff. Turns out in Kubernetes land, SSHing is not something you do, right? It requires high availability and performance. A database can't go down. It's very hard for it to recover, things like that. And it has to have high performance SSDs, things like that. Of course, obviously, it needs to store persistent data, otherwise it's not called a database. But MongoDB is not cloud native. A lot of databases can kind of deal with node failure, deal with new member addition, deal with all this kind of non-cloud stuff, cloud stuff very easily. MongoDB sadly cannot. It really depends on hosts. And it can't be load balanced, at least not easily. You should really connect to all members of the replica set. You can't connect to a load balancer service and have the requests pushed through like a proxy. You can, but it's not native again. So what we're going to do is use a few things that were released in the latest version of Kubernetes, especially something called stateful sets. So the first thing we're going to talk about are persistent volumes. These are data volumes that persist even if the pod restarts or moves. Then we have sidecar containers. It's basically a container that helps the primary container do its job. So we'll take a look at why we need that with MongoDB. Then we have stateful sets, which are basically a set of pods that can scale horizontally, just like replica sets, but each pod maintains a consistent network and disk identity. So this means that if you lose pod 2, you'll get pod 2 back and it'll attach the same disk that it had previously, which is very important for databases. And finally, the last piece of the puzzle is a headless service, which is a service that does no load balancing, but instead exposes the pods directly with their own DNS names. So what we have here is our headless service and our MongoDB stateful set. The first thing that happens is if a volume does not exist for that pod, it'll provision a volume for you. Then it'll spin up the pod, and the MongoDB instance will store its data in that volume. And then we say, I want 3 of these, so it does 3 of this for us. Cool. Now, what happens is the configuration sidecar is a little Node.js process that actually has a Kubernetes API built into it. So it'll talk to the headless service to discover the other members of the MongoDB replica set. Now, this is really cool. This means we don't have to actually configure MongoDB manually. Instead, we just have the sidecar auto-configure our cluster for us. So once it talks and figures out the rest of the members, it'll create the replica set for us automatically. And when our app wants to talk to the MongoDB replica set, it bypasses the headless service and talks directly to the pods. So the first pod is called mongo0.mongo, mongo1.mongo, and mongo2.mongo. Right? We're not talking to the Mongo service. We're talking to each pod directly using the headless service. All right, can we switch back? Sweet. So at this point, I have our IP. We can obviously go there, but you can just take my word for it. It works. Here you go. That's an error. That's great. I don't even know. All right, did I do something wrong? Who knows? It's not interesting. Let's just keep going. So I'm going to make stateful 1. And I was too lazy to even copy the YAML, so I just didn't get from GitHub directly. So the first thing I'm doing is creating this thing called a storage class. And a storage class is not technically necessary, but I like it because I can control what kind of disk gets provisioned. And I really want an SSD. So I made a new storage class called Fast that provisions Kubernetes. It makes Kubernetes aware of the GCE persistent disk and makes you able to provision SSDs on the fly, which is nice. And now I'm actually going to create the MongoDB service. And here's what happens. You can see that we have our mongo-0 spinning up, but we don't have the other 2 replicas. This is because a stateful set actually spins up the pods one at a time. And if you think about it, this is really important for most traditional databases because the replica set has to be created first before a member can join. And so what this ensures is that you don't have 2 people thinking that they're both the primary, and then you have to do re-elections and things like that. Instead, we wait till the first container is created before starting the next one, and before starting the next one. Obviously, the first step is to actually create those persistent disks. So you can see that we have 3 persistent disks being created already, and they're bound to our nodes. So we have storage mongo0, storage mongo1, and storage mongo2. Now, the other thing to notice is the Mongo service itself. So we have our Nginx deployment on the very bottom that has a cluster IP and an external IP. The Mongo service has a none for cluster IP. Now, you might think that's kind of weird. And it is. It's because it's a headless service. There is no load balancer for the Mongo service. We don't need it. Instead, it exposes the pods, mongo0, mongo1, and mongo2, directly to our application. OK. Now, let's just go back to the slides. We'll let that create in the background. See if this works. Nope, doesn't work. Oh, it's the wrong copy-paste. See, that's why. There we go. See, it works. No one can see it. No one can see it. Can we switch back? I want to show people that I actually did this. I'm just talking to myself here. There, see? Ha ha ha. I win. All right, let's go back. All right. So if you want to learn more about how to do that a little bit more deep, I have a blog post on the Kubernetes blog. You can go to that short link to learn more, or you just search for that. I mean, there's a good search engine out there, I heard. And it'll give you that. I go into pretty much exactly what I did, but in detail. I explain what the YAMLs do. I explain what the sidecar does, all that kind of good stuff. OK, so now let's talk about, in my opinion, the most interesting thing. Why is it, my opinion, the most interesting thing? Because it's the latest thing I've done, right? So new is always interesting. Here's the deal. I have friends in Azure. I have friends in AWS. Public clouds, all of them, have data centers around the world. Look at how many there are. There's just like dot, 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 dot. Like you can't even count them, right? And we just launched 3 more today, right? California, Canada, and the last one, which I forgot. It's OK. They're all very important, don't worry. But the thing is, there's so many of them. Do you know how many people do this? So many people do this. They just say, we're going to go to production in one zone, with one provider. And I'm telling you, I know people do this on GCP. I have friends at AWS. They say the same thing happens there. It's like, why? Why? Because it's hard, right? Yeah, multi-region is hard. Multi-cloud is hard. But it's 2017, and we can do better than this. And Kubernetes is really trying to make it easier, but it's still hard. It's still hard. Don't get me wrong. But we have to do this. Otherwise, when a cloud provider goes down for any reason, and we all do, things just break, right? I saw a great blog post saying, because of Kubernetes, with the S3 outage, they failed over just seamlessly without any sort of downtime because they had this redundancy. And this happens to everyone, right? It's not just AWS or Google. It's everyone has downtime. So with Kubernetes, you can really hedge against that. So we're going to talk about 2 things. The first thing is the federation control plane. And it's basically a service that manages the global state of all the federated clusters. And when everyone says control plane, all it means is global state management, right? It's like a global variable that's managed somewhere. It's a fancy word for that. And the really nice thing that came out recently is the kubefed tool. How many of you have heard of this or used it before? A few people, cool. So if you've ever set up federated clusters before, it was a pain. You had to deploy all these YAMLs and config maps and all this stuff. With the kubefed tool, it's a few lines and like kubefed and just done. So, almost. That's why I'm here talking about it, right? So we're going to take a look at that. Can we switch to the demo? All right. So what I'm going to do is I have a huge makefile that looks something like this. It's beautiful. And we're going to talk about some things we have to do before we can get started. So the first thing is federated clusters require DNS. And this is because if you want to do cross-cluster service discovery, you have to, and especially cross-cloud service discovery. Say that 10 times fast. You have to have a DNS system that can route traffic over the public internet. Even if you're using private DNS, you still need DNS. And so, oh, hello. OK. OK. Weird. OK. Can I just unplug this and plug it back in, or what should I do right now? I'm confused. I keep talking. So anyway, you need DNS, things like that. I'm going to unplug this real fast. So what we're going to do is actually use Google Cloud DNS to configure our clusters. And I'll plug it back in now. Yeah, there we go. So, kind of. Oh, man. All right, everyone gather around. We'll just look at my laptop. Huh. Nope, there we go. Cool. So right now I bought a domain name called worldclassmicroservices.com because it's very long and no one likes long domain names, so they're cheap. And right now it has nothing. It just has a few name servers and that's it. But what I'm going to do is I've created that managed zone and I've given it a name. So now Kubernetes can actually connect to that. Now what we're going to do is actually use the kubefed tool to deploy federation. Here we go. So that's the line we're going to run. Kubefed init And this is the name of our federated context, which is world scale microservices. And we're going to give it a host cluster. Now, this is really interesting. We're actually hosting the controller for the multi-federated clusters inside of a cluster. So it's self-hosted. So you're not wasting any resources with another host controller kind of thing. So we're actually hosting it inside one of its own clusters, which is really cool. And then the last thing is we're going to pass it that DNS zone name, infra.worldscalemicroservices.com dot. Very important to put that last dot there. If you don't, it's not going to work. I learned that the hard way. So the next thing we're going to do is actually, oh my gosh. All right, we're going to join all the clusters into our federated service. And what we're going to do is just loop through all the clusters that we have. And here's the clusters that we have. I've made one in all our public data centers that you can launch something in today. So Asia East, Asia Northeast, West, Central, East, and East, West, whatever. Why do I have two West? I have no idea. OK. This is weird. OK. And non-federated is what I was running the other demos in. I don't understand what's going on, but that's OK. So right now, we've had our control plane deployed, and it's running our API server at that IP address. So now what I'm going to do is just loop through all the different clusters and run the kubefed join command. And this will just dump a bunch of crap on the screen, but that's OK. I'll look at the first one. So it says kubefed context world scale microservices. So that's our federated context. Join cluster. And the new cluster is going to be cluster Asia Northeast 1. Then we're going to give it the cluster context and the host cluster context. And that's basically all you have to do, and it's automatically joined into the cluster. So now if I go kubectl, actually, let me do this. Here we go. So you can see that we have all 6 of our clusters up and ready, right? And you just had to run with the context of world scale microservices, which is our virtual, federated context. Cool. OK, so now there's one more step, which is very critical to get this working. And that is actually updating the DNS controllers in all of our clusters. So right now, all the clusters just understand themselves. They don't understand the outside world. It's a big, scary place. What we want to do is make it so that they connect to that new DNS managed zone that we created, right? The infra.worldscalemicroservices.com domain zone, and use it. So to do that, before we had a bunch of complicated stuff, patch the Kubernetes DNS, all this crazy stuff. Now all we have to do is deploy a config map, which I'll talk about more later. So I'm going to create a config map that basically says the federated domain is that. Infra.worldscalemicroservices.com. And now I'm going to sleep for 20 seconds and do something really weird. I'm going to kill all the DNS pods. Why? Because DNS is sticky, and I want to make sure that they all die and re-get the new DNS configuration. I'm not 100% sure if this is needed, but it works well. So if it works, do it, right? So I'm just going to go through every single cluster and delete kubedns. And because it's running under a replication controller, it just spins up another one, right? Easy. I don't even have to care. Cool. So now we're done. We have set up 6 federated clusters around the world. We just set up 6 federated clusters around the world. There we go. All right. Can we switch back to the demo, or not to the slides? So you might be wondering, why didn't I just make a really big cluster that just spanned the whole world? Why did I go with the second one that looks a lot more complicated and looks like Christmas? It's because of reasons. And the reasons are, what if that VM on the left is in Australia and the other VM is in Singapore? Well, they probably shouldn't talk to each other if there's a closer one, right? And what happens if this just dies? What if the cluster dies? All services around the world just die, right? With the second option, even if the global control plane goes down, all the local clusters are still up and running, functional, fully functional, right? You just can't address them at the global scale. And if little clusters go down, it's OK. traffic will reroute intelligently to available clusters. How? It's something like this. So if service A, the app wants to connect to service A, obviously it'll connect to the one in the cluster. But if it wants to connect to service C, it'll say, hey, there's nothing available in the cluster. Let me go to another cluster. That's pretty cool. This means that you don't have to have your services running in every cluster if it's not a highly used service. In fact, we'll talk about something like that in this part right now. Because if you go to mywebsite.com, from there, you probably want to go to the Sao Paulo data center, not somewhere else, right? In fact, your users around the world probably want to go to the data center closest to them. But they all want to just type in mywebsite.com. It's super annoying when I have to type in mywebsite.uk or mywebsite.whatever, right? I just want to type in mywebsite.com and get the fastest result. Turns out we have this. This is an actual map. Those black points are actually our points of presences around the world, which means that if you connect to one of these, you're routed automatically using SDN networking, right? So we have an Anycast system to the closest data center. What this means is every single one of these points of presence broadcasts the same IP address, and the user connects to the closest one automatically. This means you're not worrying about like DNS configuration or anything like that. You just say, I have one IP, Google, you take care of the rest. And so how do you do that? Again, Federated Ingress. This is a native Kubernetes L7 load balancer and router. And it's federated, which means that you get one IP address for all of your clusters. And the way you do this on Google Cloud, of course, is the HTTPS load balancer. Now, this is our global L7 load balancing solution with a single IP address, SSL offload, and in alpha, IPv6 support, which is really, really good. So let's take a look at how that works. So what I'm going to do is just deploy all my microservices right now. So I'm going to say deploy, deployment, deploy service. The first thing I want to do is Redis. All right, here we go. Boom. Then I'm going to do the meme creator. Sweet. Then I'm going to do, what else do I have? I don't even know. Let's see. I'm going to do the website. So this is our web front end, and we're good to go. Now, I'm also going to deploy our MongoDB stack, and because it's only in one cluster, it's a little bit different. Awesome. And I'm going to deploy this little thing called database helper, which I will talk about in a second. Sweet. Now, if I do a make get service, I'm just going to loop through all the clusters and get all the services. So you can see that with just those commands, it basically federated all of these tasks into all 6 clusters, right? I ran it on the world scale microservices context, and because that's a virtual federated context, it automatically distributed all the pods into all the clusters, right? I didn't have to log into each one and deploy. So, of course, what we want to do now is the ingress. So let's do that. OK. So can we go back to the slides for 1 second? Perfect, thank you. This is all I need to do for Ingress. And this creates that global load balancer. You can see that looks really simple, except for one line. That weird line that says kubernetes.io/ingress.global static IP name Kubernetes ingress. So this is because we need to actually give it that one static IP address. Otherwise, it'll all try to bring its own. And this was really simple to do. Can we switch back to my laptop? All I had to do was this. Where is it? Let's see, Ingress, which is somewhere here. gcloud compute addresses create Kubernetes English -- global. This will create a global IP address for me on Google Cloud. Once I do that, I can use this Kubernetes Ingress in my Kubernetes natively. I don't have to actually go ahead and click any buttons on the UI or anything like that. So now if we go back to our networking page right here, in this networking page, you can see that I have these TCP load balancers being created. And those are for the database helper, which I'll get to in a second. But we also have this sweet HTTPS load balancer created. And so you can see that we have all our backends automatically added to it. Of course, it's not healthy yet. It's still spinning up. And each one of them has just this one IP address. So if I run make get ingress, you can see that all of my clusters all have the same IP address for the service, all over the world. And it's probably still spinning up, but let's try it. Still spinning up, that's OK. Now, we'll wait for that, and when that's going up, we'll just go back to the slides real fast and talk about configuration. Because why not easy coding, right? Why is there no term called easy coding? These are interesting, the regional buckets. For a lot of people, they want their data to be regional. They don't want it to be distributed around the world. Sure, you get a little bit less uptime, but you want it to be cheaper, maybe, mostly for memes. Who wants to pay for memes? And you want it to be regional so it's faster. But where? How do you know which bucket to write to, right? US Central, Asia East, Mars. Oh, wait, that's a leak. Sorry. Whoops. No, we're not. Mars Data Center, it's a rumor. We don't have one of those. You could do something like this. You can get the current zone dynamically, because GCE will report what data center it's running in. And then you have this huge mapping table saying, if I'm running in US West 1A, then use bucket 1, and oh my gosh. Every time you add something new, right? Let's say you want to add S3 into this. Well, OK, got to go edit it, right? And that sucks. What if you could just do this? Just use the environment variable and automatically get it. That sounds good to me. So what we're going to do is use a config map to store that information. So this is basically some configuration information that's exposed to a container, either as an environment variable or a file. And then a secret is basically a config map, but obfuscated. There's a lot of debate in the community over it's not encrypted. Yes, it's not encrypted. You can use Vault. Kelsey has a great tutorial on how you can use Vault to make truly encrypted secrets. But yeah, right now, the default thing is just obfuscated, just to keep in mind. All right, so let's go back to the demo. At this point, I hope it's up. Let's see. There we go. Awesome. So here is my thing. So you can see that it's detecting that it's running in the US West zone, obviously, because we're in California. And here I have this interesting website that I hope works, because it's not mine, called GeoScreenshot. And I'm going to take a screenshot of this IP address from Germany, Singapore, and New York. Let's go. OK. Can people? No one can see that, right? Let me try to zoom in. You can see from Germany, it's Europe West, which makes sense. From Singapore, it's Asia East, which makes sense. And from New York, it's US East. So yeah, this is actually really working. And if you see this on YouTube, it's not going to work because I'm going to turn the service off. So don't even try it. But it works, and it's really cool. So obviously here, we're going to be in the West Coast. I can't fake my location. Google's pretty smart about that. So we're just going to use the West Coast buckets. So what I want to do is do this thing called setup buckets. And it's going to fail, 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 fail. Why? Because I already did it, kind of because nothing would have actually launched if I didn't have the config map. If you don't have a config map and a deployment depends on that config map, it'll actually be pending until that config map is deployed. This makes a lot of sense. What I did is I made a different config map for every single cluster with the same name. And then all it does, if we can switch back to the slides. I keep picking up the wrong one. All right. All it does is it gives the bucket name for that region, right? But you can see everything's the same except that actual value of the bucket name. So the first one would go in the US East data center. So A-East, that's for America East, I guess. And A-West, I'm not very creative with names, is America West. And if we can go back to, yep, thank you. If we go to our cloud storage browser, you can see I have basically a bucket for all of my regions. And I have this test bucket. So the test bucket is a multi-regional bucket that I was using originally. You can see that the regions are actually local to that data center, which is really cool, versus the multi-regional bucket is for that region. So if we go into our US West bucket, you can see that it's currently empty. Now let's make a meme. My friend Cameron has generously donated his beautiful dog and cat. So they say, puppers are the best. And create. And we get a pupper. Oh, we don't get a pupper. Yay, no pupper. What's going on? Uh-oh. Demos. Oh, why did it not work? Because I don't have my image creator image store. So it's just not even storing any images. Gotta do that. Deployment, deploy service, image store. There we go. Sweet. Now let's do a make get pods. Make sure that's up and running. Here we go. Got a little crash loop. Oh, interesting. So our image store service is creating. I have a bad feeling I can't access Docker Hub from here. Huh, interesting. So basically our MongoDB pod is not creating, which is really interesting. It's dependent on Docker Hub. Everything else is not. So I wonder what's going on. But, and this is why this is crash loop backoffing, because the database helper is trying to connect to our MongoDB replica set, which is not existing. That's OK. So we can see our image store service is creating. The nice thing about microservices is that they can fail with some grace. Let's refresh that. Here we go. You can see that because the image store service is up and running, those requests got created. Oh, man, come on, guys. Who is that? Cloud is angry at you. And if you go to this website, you can make memes, sure, go ahead. Just do it. But because MongoDB is down, the searching will not work. The interesting thing is, all of these memes, once Mongo comes back up, will be saved. And we'll talk more about that in a second. But around the world, these will be stored in different buckets. And here, if we refresh our bucket, here we go. A bunch of people are making memes. If anyone puts anything inappropriate, I'm not even going to try. All right. All right, we're going to close the website. There we go. Not tempted. All right. So if you can go back to the slides, please. Cool. So this is the other stuff. Let's go back. And this is I think the most important part of the talk. Everything else is great. It's really like, wow, we did stuff, right? But this took me basically all of January to make by myself, right? All 6 microservices. And I kind of learned a lot about building microservices. The first thing you have to think about is this, sync versus async. So synchronous point-to-point communication, right, is pretty easy to do. And I think Kubernetes really makes it easy to do more than just normal. If you have your app and it wants to talk to a service, it just makes a request to the service. And that automatically load balances to available pod, and the pod gives it back. It doesn't go through the service. I don't know why I did that. It goes directly to the pod. But it's pretty easy, right? I don't have to worry about how many pods I have or anything. I just hit the service and we're good to go. This can be done with the REST API. It can be with gRPC or any sort of RPC framework. Either way, service discovery is basically free, right? And it feels native to Kubernetes. Here, I would have 3 tweets that say, you can't do microservices with sync, but legal wouldn't let me put tweets on my slides, so it's blank. But just imagine the tweets there, right? Angry people saying, you have to have async, otherwise it's just a distributed monolith. And I kind of agree and kind of disagree with that. This is what an async kind of looks like. Your pod puts something into a work queue. The other pods just kind of read from that work queue, finish the work, and maybe put it into another queue for the first pod to consume. And so if you look at our architecture for creating a new meme, I feel that these two pieces really fit the async nature. Why? Because if I say create a meme, enter, and nothing comes out, it's broken. It doesn't matter if it comes out in like 10 seconds. Async does not matter. It has to be synchronous. I want it now, right? Through the lifetime of the request, it has to finish. However, storing the image in the back end needs to actually finish. It can't fail, right? So that needs to be asynchronous. And it doesn't matter about performance as much like in the request, the lifetime of the request. Instead, it matters that it gets done eventually. And it gets done consistently. So what I did is database helper is actually listening to a pub subtopic. And this pub subtopic is getting requests from image store. And once that request comes in, the database helper is talking directly to MongoDB and putting it in. But the other way around, when you want to query the database, that's a synchronous service. The database helper exposes a RESTful interface, and I query MongoDB through that REST proxy. Do not expose your MongoDB to the internet. Don't do it. And use passwords, people, please, please, please. So Google Cloud Pub Sub is an asynchronous message queue, many-to-many communication, fully managed. It's no-op serverless. It just scales to millions of messages instantly. You don't have to warm it up or anything like that. There's a gRPC API that's really fast and a REST API that you can use as well, and a bunch of libraries for about 10 languages, the normal 10 languages that we support on Google Cloud. So before I go to the next one, this is, I think, really important to understand why you want something like this. If you've ever had, this is why I said, those memes won't be stored in MongoDB now because the database is down, but they'll be buffered in PubSub, waiting for the database helper to come back up and read from them, and then they'll all come in. So even though I had database downtime, it's still safe sitting in PubSub. And of course, I work for Google Cloud. I recommend using one of our managed databases. But for a lot of people, they want to run their own. So I'm not going to make any judgments there, only a little bit. So the other thing I want to talk about are the Stackdriver tools. How many of you been to a Stackdriver talk today? OK, fair amount. I like them a lot, mostly for something like this. Logging was pretty important. Now, it's not the most beautiful logs viewer, but when you have 6 microservices times 6 clusters, right? That's, who can do the math for me? 36. The answer is 36. 36 different services running around the world, right? With Stackdriver logging, I was able to take all of those into one centralized viewpoint. I can go to any of my clusters, any of the containers in my clusters, and see the logs right there. Something I didn't think I would use, but ended up using because I'm really bad at writing code, was tracing. So this is a trace graph. This is an actual trace from one of my requests. Who can see the really weird, what in the world is going on thing there? I was actually not closing a stream correctly. I was never returning. And so the process would just start again after 30 seconds. And so you can see that really weird, it's kind of blurry on the screen, but it goes from a few, like 100 milliseconds, 100 milliseconds, few hundred milliseconds to 30,000 milliseconds, and then a few hundred milliseconds, right? So that was clearly something broken, and I could not figure it out. But when I saw it in this trace, it was like really, really easy. And because I write in Node.js, except meme creator, which is in PHP, interesting fact, it's just Google Cloud start trace. It's like one line of code to get all this information, which is really cool. And then there's so much more. Yeah. This is a small list that me and a coworker created over drinks one day. And we're like, wow, there's a lot of stuff to talk about with microservices. Everyone says they're easier than monoliths and something, 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 or I don't know, whatever. But you have to think about a lot of things when you're really doing them. So people are taking pictures. This is just a random list, guys. This is not real. I'm kidding. You can take your pictures. Take your pictures of this. So if you want to learn more about microservices with us, me and my coworker Ray Sang, who's another cloud DA, we want to create a new blog post / video series. This is me saying it now, so I'm forced to do it later. Follow us on Medium and Twitter, and hopefully we'll announce something later this year. The two of us kind of sat down and were like, wow, there's so many unknown knowns known unknowns, unknown known knowns, and like who knows what's going on in this world of microservices. A lot of people are talking about it. Let's get practical. Let's just try to work with the community and understand what we want to do.